I am happy to have you again on my channel. Thank you for joining me. Again this morning or this time we'll continue with another aspect of whole number system, the square root of numbers, and you can also have it under the decimal numbers. But in this video we talk about the whole numbers of the square root of whole numbers. Quickly, if you have things like this is a diagrammatic representation of square roots. It can be in different forms, but we are not going to be dealing with this. Let's go straight to what we have on our screen. If you look for square root of numbers like this, we are all familiar with this. The square root of a number means what do you multiply? That number repeatedly multiplied. If this means square root, this means third root, this means fourth root, and on and on. And this means nth root. So the number of roots that you have determines what your answer will look like. Like this, of course, this is just a square root. So, and this can be written again as what number to multiply repeatedly that will give you 4. That is 2 times 2. And that can be written as 2 raised to the power of 2. Do you see this? Raised to the power of 2. So this cancel this, cancel this. So our answer is 2. Because square root and squares they cancel out each other, then you have 2. So no, at times I say square roots and squares, they are like cats and rats. So they will always cancel out each other wherever both of them appear. So that's why whenever you are looking for, okay, let's say you have something like this, you have this x squared is equal to 9, and you have to find this x. All you have to do, because it's squared, you have to get rid of this square. How do you get rid of the square? So we assume this is like a rat. To get rid of a rat in your home, what do? You introduce a cat. So just introduce a cat, the cat is square root. For you to have introduced to the left hand side, do the same to the right hand side. Then what happens? The square roots will cancel the square. They are rats, cats, and rats. So we have the square roots of this to be 3. You get that? So good. Let's get back to work. We have this. We're going to find the square root of 1225 by factorization. There are two ways you can do this. You can do it by repeated division or by factorization. Let's quickly do the repeated division method first. We have 1225. Then what do you divide with? Of course 2 cannot divide it because it ends with odd number. Let's check, will 3 divide this? 3 won't divide, but 5 of course will divide. Yes, 5 will divide. What do we have here? 5 and 12 is 4. Is 2. We have 2 left. In 22, we have 4. We have 2 left. Then in 25, we have 5. Again, if 5 goes, in 24, you have 4 left. In 45, you have 9. Then, of course, 49, 7 should go, 7, yes, 7, 1. So now I tell you, if you are looking for calculating square roots, you express this. These are the prime products, or you call them the products or the prime factors. Yes, preferably the prime factors of 1225. Express them, group them, or pair them in twos. So this to this, this to this. We're able to represent them this way, then it means this have a square root indeed. So you can now say that the square root of 1225 can be written as the square root of 5 raised to power 2 times 7 raised to power 2. You have expressed in index form here. So what happens? Like I said initially, the square root always cancel out the squares. So these square roots cancel the squares along, cancel the squares along. So now the answer becomes 5 times 7. And that gives us what? That gives us, that will automatically give us 35. So this is the square root of 1225. Let's go by the other method we were told to use in the question. The question says solving by factorization method. How do you go? If you solve by factorization method, you have to just write out your question. You have this. When solving by factorization method, it will be your sole business to know or to look out for numbers that when you multiply them together, you will get what is in the square root. And that is, of course, you have this. I know 5 times 5, 25. Then times 7 times 7. So that can be written just like what we did the other time. What our repeated division resulted into. Our repeated division will always result into the factorization method. And this will give us 5 squared times 7 squared. And that can be equal to what? This cancel this, 5 times this. And that can give us 35. I believe with that should be clear. Let's do example 2. Let's do example 2. It says what must be multiplied? Find the smallest number that must be multiplied with 176 to make it a perfect square. Now this is what you do. You use the repeated division method here. This is the only division and the easiest method you can use. Of course, there are other methods, but the easiest one, you go to here is in 17, that should be 8. You keep 1 in 16. Okay, 8 again, 2 again, you have 4, you have 4, 2 again, you have 2, you have 2, 2 again, you have 11. What divides? No other thing than 11. That's 1. So what do we have here? Writing this the way we wrote the other one, the square root of 176 can be written as what? Don't forget, you're not looking for square roots. Yes, let me clean that. You're not looking for square. They say find the smallest number that must be multiplied with 176 to make it a perfect square. It's not a perfect square here because one, I said when you are having a perfect square, then you can take the square root of that number. But since this is not a perfect square, how can we make it a perfect square? This is how you make it. Look at this. If it's a perfect square, it should be able to group everything in squares, in pairs of 2s. That's what I mean. But there's nothing to pair this with here. Only 111 that we have here. So this is a number that must be multiplied by 176 to give us a perfect square. You can try it out. What is 176 times 11? So 176 176 times 11, that will give us 1936. Check the square root of 1936. Check the square root of 1936. What do you have? You have 44. So obviously, the number that must be multiplied with 176 to make it a perfect square is 11. So any number that you have after dividing or using your repeated division method to divide, and you cannot pair them, it can't square it. It's not repeated twice, like 2 twice, 2 twice. But this 11 only once. This is the number. It can have two numbers. Can, for example, have 3 and 4. So those two numbers will be the product of the numbers will be the number that when you multiply with your question, that will give you a perfect square. Here, our answer is 11. Thank you again for joining me. Do have a nice time.